50 hertz has been selected. Let's start her up. Put some glow plugs on. Ooh, there she goes. All right. First time. 50 hertz, 120,000 volts. Let's go. Ooh. I like that better. Alright, I'm going to do another test. A little bit further apart. 50 hertz. Let's go. Ooh, that's not good. Woo! The night generator didn't like that. So what I'm about to do now is try to flash over this bottle with the electrodes a little further apart, so hopefully we get a cool static look. And again, this will be at 120,000 volts at 50 hertz. Of course, ballasted at 70 amps at 240 volts. Ah, what a shame. That was uneventful. And that's all it took, is a little pinhole for electricity to go through glass. Alright, let's try it again. That wasn't good. I'll show you what was happening here. Yeah, that's not good. We don't want that at all. Stick the electrode in a little further. Wow, it actually burned the ground a little bit. Definitely not the right shoes for this, but let's take a look. She's running all right. It smelled a little bit of oil, but nothing burned. Alright, time to change back to 60 hertz. There we go. Power the whole house off of this for a little bit. Now to turn everything back on. So, it's about, I think, 33 degrees outside. It's going to dip even colder later in the week, but I don't want to run it that cold unless it's an emergency. But, so I took the batteries out for the winter. As you can see, The reason I did that is because pointless leaving them out here getting ruined with the cold when I can just make a little lithium battery to jumpstart this thing when I ever need it. So I found this NATO sleeve. It's a 24 volt, 500 amp plug. It plugs right inside of the generator, like so. I got a 4-gauge wire going up for now because when I did an amp meter test, the engine only the starter only pulls about 200 amps, so that's fine for starting it. Then I built this I bought this battery on battery hookup, and I decided to make it into a jump starter for this generator so I don't have to leave the lead acid batteries out in the wintertime. And it has a built-in contactor in there, so I kind of 3D printed this little bracket, put a BMS in here, and wired it in series with the contactor so that the cells are too low. We'll just drop that contactor out, and that way that high current is going through the BMS. I put this little e-stop here, so as soon as you turn it on, one indicator light and then another indicator light. And I also added some courtesy lights on the outside. I don't really need it right now, so I'll leave that off, but let's go ahead and start this thing. Probably haven't ran this thing in about a month. So let's actually preheat the engine with the glow plugs inside. All right. There she goes. We'll let her warm up for a little bit. Stabilize the frequency before I drop that contactor in. As you see, it does not need the battery pack to keep this thing running, and it does even say that in the manual that it does not require a battery after you jump start it. Now that the voltage and frequency have stabilized, I can activate the output contactor. All right, we got power. First step is to flip over the transfer switch to the generator from the grid. There we go. You also notice that I've added a new meter, a 3-phase ET340. Yeah, ET340 by Victron. Oh, well, it's Carlos, because whatever. But you'll notice that I hooked this guy up, so now I can actually monitor each individual phase coming out of the generator, so I get a more accurate watt reading. I also have one in the main panel as well. So now that I have better meters, I'm actually able to properly monitor it. So the reason I'm running this today is that I was looking into my heating elements for my house, because my house has electric heat and not natural gas. And I realized that only 2 of the 3 heating elements are being used. Reason being is that the wire going into this unit is underrated, so it's only a 6-gauge wire, can handle maximum 60 amps. And each phase would be pulling, each heating element would be pulling about 22 amps, so you'd be overloading it by 6, 7 amps or 8 amps. And if you had all 3 of them, so I guess the previous owner or company only hooked up 2 of them, so that left 1 heating element not being used. So my idea is if I do lose power in the winter time, that would really suck because I need to be able to heat my house, and I can't use the heat pump because it'd be too cold for that, well, in some instances. So my idea is to use 1 heating element and hook it up to, or the remaining last heating element, hook it up to the generator, so if we do lose power, it'll take a long time to heat the house up, but it'll at least be some heat, So right now, I have 2 of the legs of the transformer going out and going right into this single heating element via wire nuts, just to temporarily test it out. And we're gonna give it a try and see what we can get for heat wise. There we go. So now that I have kicked on the heater for the house, I am now enabled that 1 heating element. As you realize, leg 2 and leg 3 have just jumped up to about almost 3,000 watts each. Pull about 8 kW from the generator. So each leg is only able to pull a maximum of 5,000 watts. Overload it a little bit higher, but it seems to handle it. There you go. So that one heating element is pulling 20 amps. So again, circuit breakers are only, they might be rated at a certain amp reading, but in reality you can never go up to that amp reading. You're supposed to go, I think, 5 amps below it or whatever. There's a data sheet on each circuit breaker telling you its overload, thermal overload capabilities. So that's why you never want to run a circuit breaker at max load right at 60 amps. Same with those fuses, those are 60 amp fuses. But at least it's working. It's only bringing the temp up from the input air about 8 degrees. It's a little bit below 70. It's like 75 coming out of it. So at least it's making some heat. Now the next step in testing this generator is that we're going to test and see how it handles with the heater on, the heating element on for the house, as well as the water heater running at the same time. So if you notice here, we're actually pulling a little over 5,000 watts on leg 2. That generator can handle up to, I think, 8 kW per leg. You don't want to overload it for too long, of course, but 500 watts more on one leg is perfectly fine. Anyways, thanks for watching. I hope you enjoyed the video.